is Ali Megahead, and I'm a research group lead at IBM. And it's really an honor to be here today and hear about all the good things that Hassan is doing to the community, and happy to present this. So this work has been really multiple year worth of effort within IBM, and I think it's very interesting work. It has had a lot of impact, and we think that it's transferable to a lot of industries. So this has been done to the IT services industry, as Hassan was mentioning, but it can be, we believe that it can be transferred to multiple industries, a main one of which is the construction industry, which I know that a lot of the audience today is from. Another thing before I begin is that, as I said, it's a body of work, multiple connected pieces, and I was thinking before that presentation whether I should focus on one piece and go deep in the technical details, or should I make it more high level and cover more pieces, and I decided to do more of the latter. So I'll try to cover, go over multiple pieces without going too deep into any of them, but I will also go a little deep into one of them, the first piece of it, because I know it will be of a lot of interest to many of you. Now, of course, again, it's multiple year worth of effort, and just to give you an idea, each part of the work that I will talk about could be presented in a whole topic on its own, and I have presented it in multiple conferences before and in front of multiple companies, clients, and so on. So, forgive me if part of it is not as detailed, but we can always have follow-ups. I'm happy to have offline discussions with any of you. Okay, without further ado, let me start. I will start with some introduction of what IBM Services is. IBM Services is the organization within IBM that we did that work for. And IBM Services is the organization that builds, runs, and develops the foundational systems of the backbone of the different IT infrastructures of different companies. So their clients are typically enterprises, are companies, and they have clients of, almost all industries you can think about. So, for example, they have 4 out of the 5 biggest airlines are their clients, 8 out of the 10 leading mobile operators are their clients, the 10 largest banks in the world are their clients, and so on. So they provide IT services to these clients. Now, the way that their business work is, and here the similarity to the construction industry and a lot of industries come into play, is that it's a tender kind of process. So this business, or the part of the business we're focusing on, is a $34 billion business into 2018. So you can see how big this business is. And we're talking about deals that are worth a few million to multi-billion dollars each. So each deal, is typically in the range of $100 million, $200 million, and so on, where they will deliver IT services to a big enterprise, a big company. And they deliver it on multiple years. And that's why it's such a big kind of contract. It's a tender kind of process, as I mentioned, where it starts like any tender process, again, similar to your construction industry. It starts with a request for proposals from the client, an RFP, where the client defines what they want. And usually there are multiple competitors. In this industry, there are typically up to 10 competitors for each deal. The client chooses some of them, down selects some of them after they submit their proposals, and they engage in a long negotiation process. What we call the engagement life cycle is the time to negotiate. That's when we have the initial proposal until the client chooses one winner. It's anywhere between 3 to 12 months. And as I mentioned, in this industry, each opportunity or each deal has IT services, things like software, hardware, cloud computing, mobile computing, Unix, mainframes, and so on. There are an average of 10,000 components in a complex opportunity, and the contracts are usually 5 to 10 years. Okay, so that's really the introduction to that industry, and it's again, I think there's a lot of similarities to multiple industries that have a tender kind of process. Now, what were the main points to that business, which I think are again main points to a lot of similar businesses? First, the RFP analysis. They would get an RFP, a request for proposals document, that's hundreds, if not thousands, of pages long, and it will take them days or weeks to process it manually, to read the RFP document with a panel of experts who have been doing this for multiple years. They would get it, they would read it, they would understand it, they would extract what the client requirements are, and then they would prepare a solution to respond to such RFP from the client. You can imagine how extremely, manual, fragmented, and time-consuming and resource-intensive that is. The other problem after is costing. Now that we came up with what the client wants and what our offerings that would fulfill the client requirements are, what are our estimates for such offerings or such products or such services that we would include in our solution. And now, we will deliver this into multiple years in the future, so the cost would likely change in the future. So we need to estimate that cost in the future, and again, that's not an easy problem. Right before we did that work for them, they were using this mainly using some, spreadsheeting kind of analysis, very, very, simple calculations and so on, trying to estimate the costs, taking so much time, not so accurate mostly, and very inefficient. And then comes pricing. How do we price our contract? The trade-off, we price too high, you won't get the deal. You price too low, you might get it, but you won't make money. Pricing is very, very complex. Also, the other thing, as you all probably know, pricing is not the only thing that determines whether you would win the deal or not. Sometimes you might price more than one of your competitors, but you would still win the deal, especially for those mega deals or those very big deals. There are two competitors. One of them is pricing it at $100 million. The other one is pricing it at $98 million. The client is likely not going to choose the one that's cheaper by just 2% only because it's cheaper by 2%, but it will look into multiple other things, including the relationship with the client and whether we have done business with that client before or not, and so on. So there are a lot of things that come into play in pricing, and that's what makes it difficult. And again, before they were making it manually, but we wanted to make this more efficient. Market benchmarking. What is the market price at right now, and how can we benchmark? Again, is that market pricing? Again, we would have anonymous data because it's, as you probably know, it's illegal in almost all countries of the world to have exact pricing of different competitors. You can have some very anonymized aggregate prices, but you don't have exact prices, so how can you use that to come up with the market benchmarking for your particular proposal? That was another pain point and hard thing to do. And last, at least win prediction. Now that we're, bidding on multiple deals at the same time, how can we see the status of these different deals? How can we predict which deals are going well and which are not, so that we can take an action on deals that are not going well to increase our chances of winning them? So you can imagine that, and they had no way of doing this. They were doing this by gut feelings and by, manual predictions of the salespeople who are negotiating these deals. So you can imagine how they had a process that was manual, slow, paper-based, fragmented, and so on, but we wanted to do something about that. And that's when our team came. So again, that's another slide that shows what they had. So they had RFP being done manually, and there was no market view. Costing was done using spreadsheets, pricing using experience, and there was no win prediction. And then we came into play, and by we I mean IBM Research, which is another organization within IBM. It's the largest industrial research organization in the world. We have more than 3,000 researchers in 12 labs in 6 continents and so on. And we have very, very notable scientists, as you can see here. So we came into play, and we wanted to help the business, the IBM services business, to be more efficient in responding to tenders. And we wanted to develop AI capabilities that would help them do that. Unfortunately, we were able to achieve a long way in this. We're still doing more stuff, but we have done a long way. That's what I'm trying to share with you today. So what have we done to them exactly on the high level? Well, we brought analytics and AI to transform these subjective, time-consuming business judgments into informed decisions based on data-driven insights. I like to think of the problem as a funnel because you have a lot of potential deals in the beginning, and along the way you lose some of them, but then at the end you win some others, and you try to maximize the ones that you win out of the ones that you have in the beginning. And there are multiple stages to the process where you identify the opportunity, you get the RFP. That's when the RFP analytics come in that are able to automatically, and that's what we have done. We were able to automatically read the RFP, extract the client requirements automatically, and then map it to the client offerings, to the optimal set of offerings that would cover such client requirements. And then we would do costing analytics, so we were able to develop another tool based on data mining and AI to do some mining of historical data as well as market data to estimate the costs as efficiently as possible and as accurately as possible. And then we do what we call price twin analytics, which is optimize the price. So we also develop some optimization-based mathematical model kind of technique that would come up with the optimal pricing for a deal. We also do market benchmarking, which is coming up with the estimates of the market pricing. And then we begin negotiating with the clients where we would predict how the deal is going. We would monitor how things are going, and we would do the same tool that we developed to do the pricing. It's also capable of doing repricing, meaning that when we negotiate something with the client, it will tell whether you negotiate with the client, you might change something in the deal, and you need to reprice things. So the tool would help you do that. Now you can imagine how now using our tools one last thing is that deal win prediction. We will also predict. We built a prediction tool, an AI-based prediction tool that would predict how deals are going and bring the deals in the pipeline, so that the business take an action on deals that seem to be troubled, deals that seem to be going well. Now you can imagine how extremely useful this has been to business, and I'll show you testimonials from the business, and I'll show you the quantitative and qualitative impact of what we have done towards the end of this talk. But you can imagine how they are now using automated tools that are optimized, that give them more accurate costs in a fraction of the time that it used to take them. So they used to take days or weeks to just analyze one RFP. Now it happens in minutes with a very high accuracy. They used to do costing and pricing in again days. Now it happens in a few minutes, much more accurately and much more efficiently, and so on and so forth. I know I would have loved for this to be more interactive and have you guys ask me questions in the middle, but I guess that might be a little challenging. But I don't know, Hassan, if there are any questions in the middle, please feel free to give them my way. Otherwise, I'll just continue and then I can take questions towards the end. Okay, so that's another view of the different tools that we have done. And what are the techniques that we used? We used all different AI techniques you can think of. Text mining, natural language processing, machine learning, engine programming, black box optimization. And importantly, we customized a lot of these techniques. So a lot of out-of-the-box known techniques were not really that efficient in solving the problems because they are very complex problems. And when we use known techniques, they wouldn't give good results. So we had to come up with our own novel techniques, and we did a lot of innovation. Just to give you an idea, we filed over a dozen patents to the U.S. Patent Office on the ideas that we came up with that really build on the current state of the art to come up with innovative ways of solving these problems. And we also wrote a lot of almost 20 scientific papers published in top scientific conferences and journals that talk about how, what we have done and how we did it and what the results were. Okay, now with that, let me go into each of the problems that or some of the problems I'm showing here. The RFP analysis, costing and pricing are together, and then deal prediction. I will talk about RFP analytics in a little detail, not totally detailed because again there's no time for that, but I'm just trying to give you some idea, especially those of you who are interested in data science and the technicality behind it would hopefully find this interesting. And then I'll give a very high level of costing and pricing and a very high level of deal win prediction. Okay, so let's start with RFP analytics. Well, we do, again, the objective here is that we have the RFP document, the request for proposals document. We want to automatically, cognitively, using the computer, read it, extract the requirements, and then map them to our offerings. So the first step is that we extract the client requirements. And we do this at several steps. First, we would do the structure. The first step actually is more of a software engineering step rather than an AI step, to be honest with you. And the idea here is to do what we call structure analysis of the client document. And the reason we had to do this is because RFP documents come in all kinds of sort of forms, all sorts of forms you can think of. They could be DOC documents, DOCX, they could be PDF, they could be Excel, they could be PowerPoint, they could be, you name it, XML. There's different sorts of formats. And it's not that straightforward as you might think of how you can identify the different sections of a document. So if you have a document in Doc or DocX might be easier, but PDF is hardest actually. If you have a PDF document, it's not that straightforward to identify the different sections. Human beings can do that. So when you look at this, you would understand that end user computing is section 2.3.5, and then desktops and laptops is one subsection below it. But then the idea behind this step is to have the computer or the model, that the data model that we would use to build the AI capability understand this exact taxonomy. So that was the first step, and again that includes a lot of software engineering kind of work where we do a so-called document object modeling in order to try to identify the different sections, tables, paragraphs, documents, and so on, in order to identify the different parts of the RFP. And then we try to extract client requirements. Now, you could do text mining. You could try to throw the whole document that you read to one of the text mining techniques. There are a lot of even open source text mining models. You can do that, but I can assure you that you won't get good results, and we try to do that. But then the way we did it, which had a lot of novelty to it, turned out to work much better. And the results showed that it works much better than traditional ways. So what have we done exactly? And again, I'll try to be brief, but give you the high-level idea. The idea is that we first identify the different sections, classify the different sections. So we do classification of the different sections into one of four categories. One of them is in-scope sections, meaning that they are sections that have client requirements. Another one is out-of-scope sections, sections that do not have client requirements. Ambiguous sections are ones that we are not able. We might have client requirements, but we're not sure. And then miscellaneous are sections that do not have client requirements, but they have other useful information, such as the bidding process, the deadlines, things about the client contact information, and so on. So we do such classification in order to, later we would use the in-scope and ambiguous scope sections in order to further extract the requirements for them, because they are the two sections that might have requirements. How did we do such classification? We found that the best way to do that is to use bags of words. And we do all other sorts of text mining that you might know of as well, but using a bag of words, that keywords that we extract from experts turned out to work best. And these are some examples here. So when you have a statement of work, project requirements, functional requirements, you know that this is in scope. When you have proposal due date, RFP process, you know that this is miscellaneous. So we try to classify each section what it is exactly based on such keywords and their frequencies and so on. And then we filter the exact requirements where we look into each of the two categories that might have client requirements, and we do some binary classification to classify each sentence in them, whether it's a requirement sentence or not a requirement sentence. And then later on, we would extract what kind of requirements exactly the ones classified as requirement sections are. We also do a special handling for tables and bulleted lists, because a lot of tables would include requirements and a lot of bulleted lists would have requirements. So we did some special handling for that. Now, how do we extract, or how do we do such classification? We do some language processing in NLP technique, where, for example, this is one example of how we extract the linguistic features, and that's a little more traditional for those of you familiar with NLP, but just to give you an idea how we would extract the different features, linguistic features of the sentence. So that way, we have extracted requirements, we have classified sentences that are requirements, and we have really extracted these requirements. The next step is to map them to our offerings, what we can offer. And to do that, we solve an optimization problem. Why do we have to solve an optimization problem? Because we have a lot of offerings, and each requirement can be fulfilled by more than one potential offering, and each offering can fulfill more than one requirement. So we need to find the optimal minimum set of offerings that would fulfill these requirements at minimum cost. And, if you have a small number of offerings and a small number of requirements, you can think of this manually, but because you might have an exponential number of offerings and an exponential number of requirements, you have to do this more smartly. And that's why we do it through some optimization model, some mathematical optimization model, which again is not for those of you familiar with mathematical optimization, you might think that that's a set covering problem, which is, but it was also not trivial, because the cost of these offerings does not have a closed form. Why is that? Because, and I'm sure there will be something similar in the construction industry, where each offering, there is a team that works on the cost of that offering, and they develop a lot of, big complex tools on how to determine the cost. If you give me some of the details about that offering, so for example, cloud computing offering, if you give me how much RAM and CPU and disk storage and some other details, that tool would give you the cost of it, but it does not give you a very exact formula of how that cost is being calculated. So that's why that optimization model had to use what we call black box optimization, where we can query the cost for any solution and get it back. Actually, in our case, it used to take 15 seconds for each query to get the exact cost back, but we cannot really have a closed form optimized for mathematically. So we do some black box optimization. Now, there are known techniques to do black box optimization, but they take a lot of time. They are not as efficient. And the tool that we built, either this tool or all the other tools that I have been talking about, are interactive tools that we built with a very complex user interface software for the business users to use. And it's interactive, so they cannot, put something and just wait for hours for it to work. They want it to be very fast. So we had to come up with a way to accelerate it and make it more computationally tractable. And there's some, interesting way of doing it, but again, I won't go into details for the sake of time. But the idea I wanted to convey here is that we do optimization in order to convert the requirements to the set of offerings that we will include in the solution. These are some, examples just show you how successful this has been. These are classification accuracies on some client documents, and you can see that we are in the 80s and 90% accuracy, which has been great. These are results for some on the requirement side, how much requirements we were able to capture, and you can see that they're also quite high in almost all of them. And then after we do RFP, so far we have done RFP analytics. We extract the client requirements, we add them to the offerings that we will include in the solution. Now we want to come up with the cost of that solution and the price of that solution. And to do that, we do costing analytics and pricing optimization. This equation on the top is a known equation in the revenue management field of science, where they try to maximize for P. P is the price, C is the cost, PR is the probability of winning at any price P. So the idea here is give me the optimal price that would maximize this. And this is the expected profit. So we try to maximize the expected profit. But to solve thrust optimization problem, where P is the variable we want to solve for, we need to have C and we need to have PR of P. C is the cost, so we need to estimate the cost first. And for that, we did a whole algorithm to do so. And then we also need to estimate PR of P, which is the so-called price sensitivity, which is the probability of winning a deal at any given price. So for that, we built classification models. And for C, we did, as I said, some customized costing algorithm where we would choose similar deals in the past using some criteria of similarity, and then we do cost mining, and we use some recommender system and so on. Again, going into details not possible because of time, but happy to discuss details with any of you. Then last but not least came the win prediction, where we want to predict how the deals are going, and we want to come up with a priority list of how the deals are going, where deals on top are going really well, deals on bottom are going really badly, in the middle are the ones that could go either way, so they are ones that the business should do some action on. And to do so, we did some analysis of both the structured and unstructured data. So we built classification model on structured data, and we also analyzed unstructured data. What is the unstructured data here? Well, when salespeople go to negotiate with clients, they write meeting minutes. They write how the meetings went. So they would say the meeting went well, the client liked our price, but they say that HP had a better price for cloud computing. The client liked our solution, but did not like how long it will take us to deliver it, and so on and so forth. So we have historical data. We do some customized text mining in order to analyze them, and we also analyze the structured data. What are the structured data? They are data like client geography, client industry, deal price, deal components, and so on. And then we combine both analyses into one in order to come up with one score for each deal, which is the probability of winning such a deal, to come up with the ranked list that I talked about. So that's win prediction. There are details on how the unstructured data is analyzed for the win prediction, but I'll skip that for the sake of time. Now, I have touched on the novelty and the algorithmic part. In order to move that into reality, we had to do, to move that innovation into reality, we had to do implementation, which is not trivial. And just to give you an idea, we had a team of over 15 developers working full-time in order to make this happen in the past few years, and we continue to work and deliver more capabilities. So we build something, and then we add to it, we keep adding to it, improving it, and so on. And there were 3 teams working together here. The research team, which I represent, where we were, responsible for the innovation of the algorithms and the AI capabilities. The business team, which is responsible, which are the ones who will be using it, our client, who will be using it, and they were extremely important to include in this process to make sure that what we're doing is useful to them. And then the development team, which was actually doing the development production code that turned our innovation into a software for them to use. There were a lot of challenges into doing this, and I can tell you, from experience, that it's not easy at all to implement such AI solutions. You would come into challenges like trust and confidence. A lot of business users would not really trust the thing that you're doing for them, even if you show them some very good results on historical data, and you show them how it could have been much better if you had used our tools in prior deals. They would still not totally believe you, and it will take time to build the trust and confidence. There are multiple things we have done to overcome this and make them trust us. Again, I can talk about this forever, but just to give you a very brief idea, as I said, one of the best recipes is that you start small and then you build on top of it. You start small, do something small, show them the impact. They will begin to have some trust. Then you build a little more until you reach the most innovation. There's no way you build the most innovative tool, very complex, sophisticated tool right away. That wouldn't work. They wouldn't be using it, and it will create an impact. Security was a big issue. That data is very confidential. how can we build a secure system with trust and audit. There was an opposition to have a centralized web-based application collecting all the data of IBM services and to feed our algorithms and models. But again, with trust and taking it bit by bit, we were able to convince them, and it worked well. There was also a concern of, well, different geographies are different, so what you might do for the United States might not work for Europe. What might be different from what would work in South America, which is true. But then, to avoid this, we worked with different leaders in the different geographies and tried to make our tools adaptable to differences and customize differences between different geographies, and that turned out to work well. We did implementation and deployment starting in 2014, and it's still going on, and it has been very successful. So now we have such ecosystem, where we do RFP analytics, market and cost analytics, and we do win prediction. There has been a lot of impact. It now takes minutes to analyze an RFP instead of days. It takes minutes to do costing and market benchmarks instead of days. That has resulted in an increase in the win prediction and the revenue to IBM. And the quantitative impact that we have calculated is in the excess of $350 million. We calculated this very rigorously. I know I'm running out of time, so I will skip how I calculated it, but believe me, it wasn't that easy to convince the business to talk about this number publicly. We had to go through a lot of internal audit and so on. Also, we were fortunate to be a finalist in one of the very most prestigious awards in analytics in the world, called the Edelman Award, earlier this year. And to get to that honor, they had to verify that revenue impact. So they looked into the detailed numbers with us, and they verified that impact. So this is really kind of a verified impact, and that's really a very, very conservative impact, very, very conservative estimate of the impact of these tools so far in just the last year and a half or so. And it still accumulates. It will still continue to grow, and we still also continue to add more capabilities and things that create an impact to the business. I have a video, one testimonial from one of the users. I also have another video for the VP of our IBM Global Technology Services endorsing our work. I will show the two videos. Each one of them is just 1 minute, but let me just give this summary. Well, actually, so Hassan, do I have 3 more minutes? 1 minute for the summary slide, and 1 minute for each of the two videos, each of the two other videos. Is that okay?
Well, I personally think that the videos would be quite interesting to see how things would work.
Okay. Well, just tomorrow kind of videos, but okay, so 3 more minutes, if that's okay.
Okay.
Okay, thank you. Okay, so this is a video from one of the users of our tools from Germany, and let's see, I hope that you would be able to hear it.
I want to say thank you to all colleagues involved in designing, creating, and maintaining our great tool landscape. I mean, producing videos like that is a hobby to me. Because of all the improvements in that area, I do have more time for that. But seriously, it's also value to my job. I'm a technical solution manager working in global technology services. And in this job role in the past, I had to deal a lot around complex processes, many administrative tasks, and complex calculations of many iterations. Sometimes we as a team have been so stuck in these activities that we completely lost the overview of the project and sometimes the customer. Now I'm able to get automated help quickly to analyze customer requirements. I can get tailored information about the customer itself, and I can quickly create even complex global solutions and then start playing and simulating with it with many variables to find the best fit. This is really valuable and gives me time back. With that time, I can concentrate on the customer. I can focus on the solution integration and how to deal with customization and find the best win-win situation customer IBM. Thanks again for making my job easier, and I'm so excited what happens next.
All right. And then let me show you another video by actually the senior VP of IBM Global Technology Services. He's the person who reports directly to the CEO of IBM. And again, he's endorsing our work here. Again, another proof of how this has been useful to the business.
I am delighted about the progress that our expertise in IBM research and services have enabled to help clients tackle their greatest challenges. Clients all over the world rely on IBM services to design, build, and run the foundational systems that are the backbone of the world's digital economy. With the power of analytics, the research team has brought a new level of science to our business, helping deliver greater outcomes for our clients. They have gone deep into the roots of understanding our business challenges to develop novel algorithms, and we have successfully partnered across the ecosystem to deploy those tools. The result is a steady adoption and growing usage of those tools across the business and helping to bring major revenue benefits for IBM. The team's collaboration has changed the way we prepare proposals for highly valued client engagements. In the past, we spent days and sometimes weeks preparing proposals to analyze our costs. This newest effort, together, has created immense value for our services team and, more importantly, our IBM clients.
And let me now end with this. Is that we had a real business problem. We did innovative analytics to tackle it, innovative AI. It was pretty novel, as I mentioned, as evidenced by the patents and publications we did out of it. There is real implementation, deployment, and strong adoption, which wasn't easy to achieve. It was quite challenging, but we were able to do it. There has been a qualitative and quantitative impact of $350 million and growing. And then one of the main points I've been trying to emphasize here is that we really think there's high transportability of our work to other industries. Now, will it be straightforward? No, I think it wouldn't be a plug and play kind of thing. But there's a big potential, particularly in an industry like the construction industry, and that's why I was interested in talking to this community and hear their perspective on all this. Last but not least, we were really honored to have received multiple awards for this work. We were a finalist for the prestigious Informs Edelman Award earlier this year, as I mentioned. We also were the winner of the IZ Excellence for Service Innovation Award, and we got the second place in the Innovative Applications in Analytics Award. With this, I stop here and take any questions if there's time. And sorry